Despite a lifetime of the very best education, students in our classrooms are failing to learn science. Many of these students will graduate from college with the same scientific misconceptions that they had on entering grade school. To test how a lifetime of education affects our understanding of science, we asked these recent graduates some simple questions in astronomy. Consider, for example, that the causes of the seasons is a topic taught in every standard curriculum.
Okay, I think the seasons happens because as the Earth travels around the sun, it gets nearer to the sun, which produces warmer weather, and gets farther away, which produces colder weather, and hence the seasons.
How hot it is or how cold it is at any given time of the year has to do with the closeness of the Earth to the sun during the seasonal periods.
The Earth goes around the sun, and it gets hotter when we get closer to the sun, and it gets colder when we get farther away from the sun.
These graduates, like many of us, think of the Earth's orbit as a highly exaggerated ellipse. Even though the Earth's orbit is very nearly circular, with distance producing virtually no effect on the seasons, we carry with us the strong, incorrect belief that changing distance is responsible for the seasons.
I took physics, planetary motion, and relativity, and electromagnetism and waves.
I've never really had a scientific background whatsoever, and I got through school without having it. I've gotten very far without having it.
I had quite a bit of science in high school, yeah, through physics, first year, and 2 years of chemistry.
Regardless of their science education, 21 of the 23 randomly selected students, faculty, and alumni of Harvard University revealed misconceptions when asked to explain either the seasons or the phases of the moon.
When it's further away from the sun, then it gets colder.
The Earth's position interferes with the reflection of the sun against the moon.
Class 1924. The class of 1925.
To test how standard instruction succeeds or fails in reversing such misconceptions, we interviewed 9th grade students from a nearby high school. The students selected had little training in astronomy.
When it's winter, it's when the sun is farthest away from the earth, and when it's summer, it's when the sun's closer to the earth.
Why is it hotter, say, in the summer than the winter?
It's hotter in the summer because we're closer to the sun than we are in the winter.
Tell me about the different shapes of the moon.
Of the moon? When the sun's right here, the Earth blocks the sun rays, and it causes the moon to have a shadow right here. So
that the monthly cycle of lunar phases is caused by the shadow of the Earth is another popular misconception.
Can you tell me about the difference in seasons? What's different about different seasons of the year?
In the summertime, it's like we're closer to the sun, and the sun's rays are coming down, so it's hot. And in the winter, you move further away, I guess, and it gets colder.
Unlike the Harvard graduates, these students have had virtually no instruction in science.
And does the moon have different shapes? Or?
No, it's round.
It's round. Does it ever look different than round?
Yeah, it does. It looks like a half crescent. It can look like a half.
Mm-hmm. And what causes that?
Clouds blocking it. Like say you had a half moon. This is here with clouds, and all you see is the half moon.
Like a scientist in search of an explanation, this student created his own unique theory to explain the phases.
I don't know what you got some kind of can of worms here as to why kids don't understand it all.
If we went outside today and out in the grass there, we see the sun up above. Mm-hmm. What would things look like? Say at 8 o'clock.
At 8 o'clock, the sun would have the Earth would have rotated so that the sun would be on the other side of the Earth. So then it would be dark here, and we'd be able to see the other stars. Yeah.
Okay. And where would the stars be in the daytime?
They're still out there. We just can't see them because it's not dark enough.
Heather's very bright. On a scale of 1 to 10, maybe I would probably put her at the 9, a little bit above the level of the other kids. And I would expect her to know the answers to these things.
That's the sun, although it's a lot bigger.
and then there's a planet and another planet, and then there's the Earth, because it's the third planet up from the sun. And then there are 6 more planets. And, okay, the Earth revolves around the sun. The moon revolves around the Earth. So this goes like this, and that goes like that. And each time the Earth goes like this is a day. And it takes 300, oh no, I'm going to get it confused, 365 days for the Earth to go all the way around the sun, and that's a year.
You may recognize Heather as typical of your best student.
Yeah, I would expect that she can give a better explanation than the other kids could. I think she has a little bit, and she's a lot more sure of herself. The other kids, I think, might have been a little bit inhibited and were afraid. I hope she'll tell you what she knows.
But the Earth doesn't quite go in a circle. It's more of, let's see, it's more like sort of like that, I think.
On probing, we see that Heather believes that the Earth travels in a bizarre curlicue orbit.
And when it's farther away, it's summer. When it's closer right here, it's winter. Okay, it's winter when it's closer, and it's summer when it's farther away because of, well, at least for us it is. Because of this axis. When the sun's rays are indirect, it's summer, because we get warmer. When the Earth is closer, the sunbeams are direct and it's colder.
Could you draw a picture of what you mean by direct and indirect?
Okay. When the light comes from the sun, when it's direct, it comes straight from the sun to the Earth, I think. And when the light's indirect, it sort of bounces off and then comes to the northern hemisphere. It's different.
Heather believes that light can bounce, and that this somehow causes the seasons.
When it bounces off and then comes, when it's sort of, well, when it doesn't go in a straight line, I guess, it's warmer. It's confusing.
What about the moon? What does the moon look like?
Well, this is mind-boggling, though.
The moon has like 4 cycles. And so sometimes it's full, sometimes you can only see part of it. Sometimes you just can't see it at all, and other times you can only see this part of it. That's how come it sometimes looks like a sickle.
Could you draw me a picture of how that happens?
Well, if this is us over here, then we can see the moon, and the rays from the sun sort of come around, and they only illuminate part of the moon, because I guess it's the Earth's shadow or something.
Heather's private theories contradict the teachings of even the most elementary science courses.
You assume that they know certain things, and even the day that I taught it, I come in and I just assume that they had the basic ideas, and they don't.
Heather's teacher was unaware of the students' private theories as she taught them their first formal lesson in astronomy.